Hey everybody, so in today's video we are going to be going over a two variable chi-square, and if this is the first time that you've seen this video, I highly recommend you go and check out the one variable chi-square video. The one variable chi-square is going to kind of be the foundation that we build the whole process for the two variable chi-square. So I just recommend that you kind of go through that, then the formulas that we're going to look at aren't going to seem so unfamiliar to you, but that's entirely up to you. Okay, so as usual, today's video is going to go over how to solve a two variable chi-square, and I'm going to walk you through step by step how to do that. And then at the end, we're going to go over a template that you can use to interpret either your significant or non-significant results. Okay, so let's go ahead and get started. Okay, so we have a few formulas here, and this first one right here should hopefully look familiar to you because it's the exact same formula that we use for a one variable chi-square. And then we have a new formula right here. And this is the formula that we are going to use to find our frequencies expected score, okay? And we're going to see a couple new things there. So we have an FR value and an FC value. So the FR value is going to be found by adding up all the frequencies observed that are in the same row. And then the FC value is going to be found by adding up all the frequencies observed in the same column. And just as a reminder, a row goes from left to right, and then a column goes up and down. And then the last one that we're going to see down here at the bottom is going to be what we're going to use for our degrees of freedom. And another way to kind of think about how to find the degrees of freedom that's a little bit more simple than this formula here is it's just going to be the number of rows minus 1 multiplied by the number of columns minus 1. So let's go ahead and get started on an example problem. A random sample of 100 college students are selected and categorized by sex and favorite animated TV show. And we've got Rick and Morty, The Venture Brothers, Bob's Burgers, and Archer as our choices. The observed frequencies are shown below. Is there a significant difference between men and women and TV show preference? Okay, so if we look at this table here, these are our frequency observed values. And all that that means is that if we went around and we asked random men, out of these four shows, which is your favorite? 21 of those men said Rick and Morty, 12 of those men said The Venture Brothers, 7 of them said Bob's Burgers, and so on and so on. Okay, so the first step in solving any kind of statistical problem is to identify what variables you're working with. So for this problem, we have two independent variables, and the fact that we're solving a two variable chi-square kind of gives that away. But okay, so for our first independent variable, we have the favorite animated TV show, and we've got 4 levels of that. And for our second variable, we've got sex, and that is 2 levels. And you can see that down here by men and women. Okay. Okay, so after we have identified those independent variables, we're going to need to make a table, and that's going to just help us to organize our information a little bit better. Okay, so what we're going to do in this table is we are going to take each level of each of our IVs and put it into a box. And so for this top box right here, we are going to go ahead and put the 4 levels of the favorite animated TV show. Okay. And then in this column here, we are going to put the 2 levels of sex. So that's men and women. And then in each of these boxes, we are going to put the values, the frequencies observed that we have in this table over here. So for the category of men and Rick and Morty, we have a value of 21. So that's going to go right here. And we're just going to go ahead and plug all of those values in. So we're going to do that for our independent variable of men. And then we're going to do the same thing for our independent variable of women. Okay, so the next step that I always do is to label each box with a letter. And this is going to come in handy a little bit later when we're adding up our rows and our columns, okay? So what I do is I just go in and in the corner, I just write a little letter. So we've got A, B, C, D, all the way through H. And you can label these however you want. If you want to do numbers, you can do numbers. But for me, it's a little bit easier to do letters just because it kind of keeps things a little bit more clear. Okay, so after we've gone ahead and done that, the next step is going to be to determine our frequencies observed for our rows and our frequencies observed for our columns. Okay, So we are going to start out with this row right here. And I mentioned just a little bit ago that rows go from left to right. So this all right here is a row, and this here is a column. So that's what I meant by rows go from left to right and columns go up and down, just to be a little clear. Okay, so for our frequency observed for the first row, this right here, all that we're going to have to do is we're going to have to add our boxes together, okay? So we are going to add box A, B, C, and D and add the frequency observed that are in those boxes. So we are going to have 21, 12, 7, and 9. And when we add all of those together, that's going to give us a value of 49. And we're going to do the same thing for the next row. So we are going to add boxes E, F, G, and H together. And that's going to give us a value of 51. Okay, and then we're going to do the same thing for each column. Okay, so for each column, so for this one, we're going to add boxes A and E, so that's going to be 21 and 10. That's going to give us a value of 31, and then we're just going to continue doing that for each column that we've got. All right, so I've taken the information from the previous slide and I've kind of just condensed it a little bit to give us a little bit more room to work with. Okay, so for the next step, we are going to be determining the frequency expected values for each cell, okay? And here is our formula right here for finding the frequencies expected. And if you can't remember from the original problem, our in value is 100. And if for whatever reason you're not given a word problem, you can still find the in value by adding up the frequency of rows or the frequency of columns. So you can either add these two numbers here together to get the in value, or you can add these numbers here to get the in value. Either one will give you our in value of 100. Okay, so here is our formula right here for our frequencies expected, and we're just going to plug in our numbers into this formula here. Okay, so we have our frequency of rows here, and so we are working here on box A, okay? So we're going to put the frequencies of rows right here. So since we are working with box A, that is from this row here, okay? So we're going to put this value down here. Okay, so that's going to be a 49. And then we're going to look for our frequency columns, okay, and we're once again working with box A, and so we're going to put this value right down here. Okay, and that's 31. And then we are going to put our in value down here at the bottom. And then all that we have to do then after we've plugged in those numbers is go ahead and solve the equation. Okay, and we've got 15.19 for our frequencies expected for box A. Okay, and then that's just going to go right up here in the box. And we're going to go ahead and repeat that process for each cell, each box. So let's go ahead and just do another one just because. So for cell E right here, we've done the same exact thing. So we have taken our frequency for R, which is right here, the 51, and we've plugged that in. And then we have our frequency column, which is 31 again, and we've plugged that in here. And then we've plugged in our in value to get 15.81. And then that's going to go right up in our table. Okay, and so like I said, just repeat that process for each box. Okay, so I have gone ahead and computed the FE values for each box that we've got. So our next step is going to be to determine the chi-square values for each cell again. And here's our formula for chi-square. Now at this point in the equation, we do not need to worry about adding up the chi-square yet. So all that we're going to focus on is this part of the formula right here. So do not worry about adding all those up yet. We're going to do that a little bit later. But we need to perform this formula for each box that we've got. Okay, so once again, let's go ahead and do cell A. Okay, so we have our chi-square variable, and we're going to do the exact same thing that we did for our one variable chi-square. So we have our frequency observed here, and that is a value of 21. So we're just going to plug 21 into here. And then we have our frequency expected value that's going right here, and that is this value here. So we're just going to plug that in. And then we are going to square that. And then the frequencies expected goes on the bottom once again down here. And so that's all that we have to do. We just continue to plug in those values into the equations and just kind of solve step by step, okay? So when we work all of that out step by step, oh, and also don't forget to round. So at this step here, So we've got 33.7561. So we want to round to 2 decimal places. So this 33.7561 is going to get rounded to 33.76. And anytime in the equation that you have any decimal point that is longer than 2, so this you've got 4 decimal places here. Anytime you have more than 2, you need to round at each step of the equation. And some professors won't have you do that. However, the professor that I have created these videos for would like you to do that. Okay, so now that that's said, moving on. Okay, so our chi-square value for our box A or cell A is 2.22. And we're going to go ahead and put that up here in the box. And we're just going to keep doing that whole process. So I've gone ahead and computed the one for cell E as well. So we've got a value of 2.14 for that one. And we're just going to repeat that process for all the boxes yet again. All right, so I've gone ahead and I have done the chi-squares for every single cell that we've got. Okay, so our next step is to add up all of the chi-squares together to get our final chi-square value. And we're also going to determine the degrees of freedom. So if we take each chi-square value that we've got, so we have all of these in blue here. So we have to add up each one from each cell. And that's going to give us our final chi-square value. Okay, so if we add up 2.22, 0.5, 0.57, and so on, that's going to give us a final chi-square value of 6.46. Okay, so we've gone ahead and done that. So now let's do the degrees of freedom. Okay, so the initial formula that I had up on the beginning slide was this right here. So it was R minus 1 times K minus 1. And another way to think about that is just the number of rows minus 1 multiplied by the number of columns minus 1, okay? So we have 1 row here and 1 row here, so that means we have 2 rows, and then we have 1, 2, 3, 4 columns, okay? So what we're going to get then is we're going to have 2 for the rows minus 1 multiplied by 4 minus 1, and that is going to give us 1 times 3, which is going to give us a final degrees of freedom of 3. All right, now that we've gone ahead and determined our final chi-square value and our degrees of freedom, we can go ahead and check for significance. So we're going to plug in our degrees of freedom here, as we usually do. And then we're going to use our table here on the left to find our critical values. Okay, so we have for the 0.5 value here, we have for the 0.1 value here, and then we have our 3 degrees of freedom here. Okay, so we're going to go ahead and plug those values in. So for our 0.05 value, we have 7.82, and then for our 0.01 value, we have 11.34. Okay, and then we're just going to go through the same process that we've gone through before. So we're going to ask ourselves if our final chi-square value of 6.46 is greater than or equal to our 0.05 value of 782, and it is not. So that means that at the 0.5 value, we have to accept HO. And so we need to ask ourselves the same question for the 0.01 value. And so we're going to ask ourselves, is 6.46 greater than or equal to 11.34? It is not. And so that means that we have to accept HO at the 0.01 level as well. Okay, guys, here we go. Last part, down to the interpretations. Okay, so for our example that we've been working with, we were not able to reject HO at either the 0.01 or the 0.05 level. So luckily for us, the interpretation of that is super easy. So all that we have to do is take our variables down here. So we have variable 1 of sex, men and women, and then independent variable 2 of animated TV show preference, and then we just plug that into the template over here. So when we plug our independent variables into our template, we get a chi-square test was performed, and no significant difference was found between men and women and animated TV show preference. Okay, so that's it for non-significance. Now, just for funsies, if you decide to do a 2-variable chi-square later and you do find significance, you can go ahead and use this template here to do the interpretation for that. So this is a little bit more complicated than the ones that we have worked with before. So I'm going to go ahead and kind of break it down a little bit. So first, we want to pull up our information for our frequencies observed, okay? And that's going to help us with our interpretation. So what we want to do is look at our frequencies observed and either pick the highest observed frequency or the lowest observed frequency. And then that is what we're going to do for our interpretation. Okay, so getting down to the template here, anything that is in red, you can go ahead and just plug in the values that we've found so far. So we've got our independent variables, we have our sample size here, our sum of the chi-square value, and then you would pick either the 0.01 or 0.05 level depending on where you were able to reject HO. So the second sentence is where it can get a little bit more complicated. So for this example, we are going to use this value here. So we are going to use the highest frequencies observed. Okay, so looking at the sentence, it says, meaning that the highest observed frequency column title is, and then how these are related, and then highest observed frequency row title. Okay, so since we chose the highest frequency observed to do our interpretations on, this here is our column title. And then men here is our row title, okay? And then you basically would just plug those in. And then when we look at this part here where it says, how are these related? Well, if you remember from the original wording of the problem, we're looking at animated TV show preference. So since we are looking at the highest frequencies observed, that means that we're looking at the highest preference for that animated TV show. So if we go ahead and plug those values in, we would get this. A chi-square test was performed and a significant difference was found between sex and animated TV show preference, meaning that Rick and Morty is most preferred by men. Okay, and so that's what I meant by the row title and the column title. So you would just plug those in here and use those however you see fit. So you don't have to do like I did and do the column title first and then the row title second. It's entirely up to you which order you want to put them in. Also, you don't have to do the highest frequency observed. You can do the lowest. So if we wanted to look at this one here, the lowest frequency observed, we can do the same thing. So all that we do is just change the template a little bit. So it's the same exact template, but down here it says the lowest observed frequency row title and lowest column title. So I just switched that up so you could see that you can do it either way. And then the results of that would show up as this. So it would say a chi-square test was performed and a significant difference was found between sex and animated TV show preference, meaning that men least preferred the animated TV show Archer. Okay, so that's it for two variable chi-square. I hope that this video helped. Thanks for watching.